5.2h, volume of a cone. A cone is a solid with a circular base that sharpens into a point at the opposite end. To find the volume of a cone, we use the following formula. Volume equals pi r squared times the height over 3. Let's see this formula in action in a couple of examples. Example 1. Find the volume of the cone below. So let's apply our formula. Volume equals pi r squared times height over 3. So let's plug in our values. Pi is pi. Let's plug in 2 inches for the radius of the base. We'll plug in 6 inches for the height of the cone, and we'll divide by 3. So this becomes pi times 8, or 8 pi, inches cubed is the volume of the first cone. Let's look at another example. A funnel can be roughly modeled as a cone that it's missing its pointed end. Find the volume of this funnel. So we see that the total volume will be the large cone minus the small cone volume. So we have to find both. Let's start off with the large cone. Volume equals pi r squared times height over 3, like before. And plugging in our values from what we see there, the radius of the larger cone, and by larger I mean this big cone, is 4. And the height is going to be 6 plus 2, so 8 over 3. So we multiply this all together, and we end up with 16 pi times 8 over 3 inches cubed. And we can simplify this down to 16 times 8, which is 128 pi over 3 inches cubed. And we can leave it in this fraction form. So there's the large cone volume. We have the short cone, or the small cone. Volume is given by pi r squared times height over 3, like before. Our new radius is going to be, this is the small cone, so our radius is 1 inch squared, times the height, which is 2 inches over 3. So the volume of the small cone is just 2 pi inches over 3. 2 pi over 3 inches. So in total, we have 128 pi over 3 inches cubed minus 2 pi over 3 inches cubed. And we can carry out just normal fraction subtraction here. And we end up with 126 pi over 3 inches cubed. Now we could reduce this to 42 inches cubed. Sorry, 42 pi inches cubed.